Okay, so now we're going to continue our work with custom functions. What we're going to do here is we are going to create a function that goes back to what we first talked about in this unit, which was trying to understand how the shape of a distribution may affect our understanding of things like central tendency. So we compared, for example, cases where the mean and the median were the same, central tendency comparison, and those were generally symmetric curves, distributions. Now, when things started getting skewed, there would be differences, vast differences between the mean and median. So, in those kind of situations, whether we looked at those differences and then said, hey, the distribution must be skewed in some way, or we see the skewness and say, how different are those two measures? Either direction kind of gives us information about what we're trying to study. So we want to do this little function that would actually calculate that difference for us. And I'm going to grab the code right here and let's look at what it means. So we're going to create this function called mm diff. It's the mean median difference, right? So it's going to subtract the mean from the median and see how big that difference is. So how do we do that in R? Well, to say to R we'd like to write a function, not just execute a function, but write a function of our own, we have to tell it that's what we're doing. So we're doing a function for a function. And it's going to take a variable from a given data set. So we're going to have to define the variable and the data set. Okay. So once that happens, what does that mean? Well, we have to calculate two things and store them into variables. The first one is we have to calculate the mean. So that mean val is the mean of the variable in that data set, and med val is median value, and that's using the median function on the same variable on the same data set. And then finally, what we do is we take the absolute value of that difference, and that will give us, a measure of how far apart they are. Again, we don't care about direction. We just want to know that what the magnitude difference is. All right, so let's go. So I'm going to paste it over this. I ran it before just to test it. All right, so here we go. The formatting does seem to matter here, and then you want to be clicking on the last part of this line. Just check this spacing, and just everything is on its own line. If you have any runtime errors. So let's open that up so we can see what's going on. So if I run it, okay, I got a blue. It's, do, and then it's, I've got a blue safe zone. And so once I know that the function, or if I think the function is okay, I didn't get any errors back, I can actually execute this function. And I'm going to execute it on the orange variable in the dataset colors. So I'm going to see what my actual difference is. 0.2. That seems pretty close. So it's like less than a point. But I mean, I don't know what that is. So now I have to do that for each of those. So I'll just run the mmdiff function on each of these variables and kind of fill in the table as needed. Once I do that, it's going to be easy for me to identify which one has the largest difference here. And then what I could do is then do the dot plot for this color and make an argument why the mean or median might be better for each of those cases. And I think that's it for our customized function there.